Hello everyone, I'm Paras, a master's candidate at the University of Maryland's Computer Science Department. This will be a presentation on a tool that I and Leo developed to further support property-based testing in OCaml through Coq. Property-based testing is a popular testing technique used to ensure that a program conforms to an executable specification. In property-based testing, users write properties of a program under test, and the tool is in charge of generating a large number of random inputs. These inputs are executed with the property, and if a counterexample is found, the counterexample is minimized and reported to the user. Some popular libraries for property-based testing include QCheck for OCaml, QuickCheck for Haskell, and QuickCheck for Coq. As an example of property-based testing, let's take a simple function called reverse that takes a list of integers as input and returns the list reversed. For this function, we can define a property that checks if the length of the original list is equal to the length of the reversed list as shown. In fact, we would expect this function reverse to be validated against this property. In this case, a property-based testing tool would generate random lists of integers and run the property test prop reverse with these randomly generated lists until the property test fails or a sufficiently large number of inputs have been validated. But how are lists of integers generated? Generators for primitive types such as lists are usually supported by default. But what about user-defined types? Take for example a common data type tree. The code here shows a generator for a tree data type in OCaml. The details of the generator don't matter much. There is a bounded recursion given some size and a choice between generating a leaf or a node recursively. What matters is that users have to write this boilerplate. Worse, as properties get more complex, so do generators. Naturally, one wonders whether we can automate this process of getting generators for data types. The good news is that many property-based testing libraries provide this kind of automation. QuickCheck, for example, which is a property-based testing library for Coq, provides this kind of automation and quite a bit more, having a lot of work and research poured into it. The example in this slide shows how simple it is to derive a generator for the tree data type using QuickCheck. Define a data type in Coq and use the derive statement to get the generator. As a bonus, this also gives a minimizer and a printer. Now compare this to the code example in the previous slide of a manually written generator for a tree. As you can see, QuickCheck's automation makes it simple to derive generators for data types. Rather than replicating this effort for OCaml, we sought to see if we could reuse it and leverage QuickCheck's features to perform property-based testing for OCaml programs. Given an OCaml file containing the target program and the property test, we parse the file to get the input types of the property test. If these input types are non-primitives or user-defined types, we parse the OCaml file to get their type definitions in OCaml and convert these type definitions to Coq using the Coq of OCaml library. The Coq type definitions are then used to define the data types in a Coq script and derive generators for them, as we saw in the previous slide. Finally, the property test is extracted from the OCaml file into the Coq script and executed using QuickCheck. Let's look at each step in more detail. The setup consists of an OCaml file containing the target program, in this case mirror tree, which is a function that takes a tree as an input and mirrors or laterally flips the tree. The file also includes the type definition for the data types used in the target program as inputs, which in this case is just the tree data type. And finally, the file includes the property test called mirror property test, which states that the mirror function is involutive. That is, applying it twice yields the original tree. The OCaml file is parsed using regular expressions to get the types of the inputs to the property test. In this case, the only input is of type tree. Since the type tree is a non-primitive user-defined type, we parse the OCaml file to get the type definitions for tree. As you can see on the right-hand side, we have the OCaml type definition of tree here. The type definition is converted to Coq using Coq of OCaml. The code on the right-hand side is the Coq type definition of the tree data type. In the last step, we construct the Coq script which contains some basic imports, Coq type definitions that were parsed in the previous step, and the derive statements used to derive the generators and minimizers for the data types. We then hijack the extraction mechanism to make sure that when QuickCheck generates trees, they will be using the OCaml definition, and when QuickCheck executes the property, it will execute the OCaml property. The only code that is then produced from Coq is the generators, printers, minimizers, as well as the glue code that puts everything together using type classes. Finally, QuickCheck executes the property test and reports any errors to the user. So I will be giving a demo of the tool we developed for property-based testing in OCaml through Coq. We have two files here, file.ml, which is the file open on the left-hand side of the screen. This file contains the target program, which is, in this case, the mirror tree function. This function takes a tree as an input and laterally flips the tree. It contains a bug currently just for testing purposes. This file also contains the mirror property test, which is our property test that takes a tree and checks if applying the mirror function twice yields the original tree. And we are expecting this property to be validated. So I'm going to be running this executable here called OCaml QuickCheck. This is the executable of the tool we developed. So it takes two arguments. The first argument is the name of the file, which here is file. The second argument is the name of the property test. So running this executable with these two arguments, it generates a file called coqscript.v. I'm going to open this file, and as you can see, this file contains the Coq script that we will be executing finally to run the property-based test. It contains the basic imports. It contains the type definitions of the tree type. It contains the part where we extract the structure of the tree data type. It contains the derive statements for getting the generators, minimizers, and printers. And finally, we extract the property test here from the OCaml file and run the property test using QuickCheck. So we're going to run this Coq script now using the coqc command. So you can see on the terminal, the property-based test is running here. Here you can see that the test has failed after 4 tests and 3 shrinks. And it has also given us the counterexample, which caused the test to fail. So I'm going to go to the file on the left, the file.ml. And in this case, the bug was that I forgot to add the recursion to one side of the tree. So I'm going to go here and add this recursion. So the bug should be fixed now. And I'm going to run the Coq script again. And as you can see, this time the property test is passing. Thank you.